So today we have Dr. Mark Nechodom with us, and he is the administrator of the Agricultural Science Division at the Montana Department of Agriculture in Helena. Been there since December of 2017. Before that, Mark was appointed in 2011 by Governor Brown in California to head the California Department of Conservation with responsibility for regulation of oil and gas production, surface mining reclamation enforcement, farmland protection, and earthquake and tsunami planning and response. How's that for diversified job description? During his tenure at Conservation, he led fundamental transformation in the regulation of oil and gas production in the state, including fracking and groundwater protection. Under his programs to integrate climate mitigation, water infrastructure, and major solar and wind initiatives in California. So before that, as a senior official in the Obama administration, Nechodom helped establish the new USDA Office of Environmental Markets, where he served as Deputy Director for Climate and Energy and Acting Director. He served as a senior advisor to the Secretary of Agriculture on cap and trade and greenhouse gas reductions, and we'll probably hear a little bit about that expertise today. His scientific career includes senior scientist with the U.S. Forest Service and research faculty at the University of California, Davis, where he led major research initiatives on biomass energy, greenhouse gas markets, life cycle analysis of renewable energy systems. So Dr. Nechodom earned a doctorate in political science and environmental policy from the University of California, Santa Cruz. So join me in welcoming.
Thanks, Bruce.
All right, thank you.
Yeah, go Slugs.
Well, a pleasure to be here. Thank you for the invitation. I think in our early interactions as I first got here to Montana and learned how to get snow tires on my Subaru, working with Bruce, and actually met Bruce at a governor's briefing on the climate action plan. Is that the term, the climate action plan? Or the
Climate assessment.
Climate assessment, thank you. In which I'd worked on actually many climate assessments in many states, but particularly in California, as governor's representative on the forestry committee, and I work very closely with the California Air Resources Board. So many of the visuals that I have shamelessly ripped off from my presentation here are from the California Air Resources Board, or otherwise known as CARB. And they are basically on the planet the most important regulatory agency in any government, establishing essentially the rules for cap and trade and climate mitigation of any meaningful scale. That was quite a bold thing to say. I hope I'm not being broadcast also to California. But Mary Nichols, the chair of the board, and I go way, way back. And so I don't say that lightly or with hyperbole. And as we get into the discussion today, I think I'd be interested in your thoughts on how that rings to you. I'm not here to promote California by any means. I'm not here to promote anything. I was actually let off the reservation for a day to come, indulge my academic inner professor for a day or so. But I want to share with you some of the things that that I've gathered in the last 20 or so years, being in the world of environmental markets, in the world of cap and trade, biogenic carbon cycling. I can say that in an academic classroom without shrinking. What I mean basically, and I'll have a slide that shows you this, carbon is cycling through the planetary system at the billion metric ton level constantly. And the question is, have we tweaked it irrevocably in such ways that climate now becomes an existential threat to humanity and the planet? Now, that's also not hyperbole. I think that is a legitimate thing for me to raise as a question. I will defer on stating my own positions on this, but I do think that climate is one of the issues that has focused us in ways that range from political systems and governance all the way to technologies at scale, has animated entire PhD programs and students and faculty, as many of you are, in asking ourselves some harder questions than maybe we've asked ourselves in the past. So when I talk about environmental markets, I want to put this in a larger frame. This is not about how to do well by doing good, despite my subtitle on my opening slide. It is really about finding multiple ways that we find efficient and effective ways of mobilizing, really at the Manhattan Project level, resources to change technology, governance, planetary carbon cycling, etc. This is a very profound challenge to me, and I didn't think so. In fact, when I was developing my research proposal for my PhD dissertation in the early 1980s, I was told by my committee, oh, this climate stuff, I presented this paper on Steve Schneider and the research going on in global change, and they said, yeah, well, you better get right in that quick because that's a fad and it'll be gone in another 10 years. That was 1983. It's not gone in 10 years. In some ways, I think the extreme urgency of the issue, I think, is much more apparent. I wanted to talk to you today about cap and trade, but I deliberately messed with the title a little bit because there's so much kind of instant reaction to cap and trade, kind of like saying climate change in red states. That, did I say that? Okay. Can we roll back and redact? No, there are sensitivities about cap and trade that I don't want to get hung up on. I'm happy to have a discussion about them, but I want to talk about a broader frame here. So the reason I say cap, trade, reduce, and improve is we constantly lose sight in the arguments over cap and trade as a mechanism, as a market mechanism, or a market-like mechanism. We lose sight of the reduce, it is a cap, it is a declining cap, and improve, which is how do we make sure that we are sustainably managing large-scale systems so that we can answer, at least my daughter and her daughter's questions. Well, what happens when I'm a department director in California, 30, 40 years from now? Do I inherit basically a dumpster fire that we're going to spend all of our resources putting out, or do we have opportunities for improved ecosystems and production systems that also feed 9.5 billion people on the planet by 2050, that also reduce radical weather events that result from radical differentials in planetary temperature regimes? Those are the questions that I feel passionately obligated to address. I don't have answers. And I am sufficiently chastised in audiences like this when we get into hard conversations, but it compares not one whit with the shame that I feel in front of a 6 or 8 year old saying, how did you manage to get us here? And what are you going to do about it? So that's the urgency for me, and that's why I'm pleased to get let off the reservation, go a little bit feral today from the department, and have a chance to talk with you about these things. One of these things works. I'm going to go back to about 10 years. I've been instructed, in fact, I should have a little leash here so I don't wander away from the microphone. I'm going to go back to the 2008 Farm Bill. And this is at a time when I was actually in Washington, D.C. I was asked to come back as a scientist from the Pacific Southwest Research Station to advise the chief of the Forest Service on carbon markets and greenhouse gases. But we were also very much involved with Congress in the drafting of the 2008 Farm Bill. Section 2709 got shoved in there by Dianne Feinstein and Colin Peterson, the congressman from Minnesota, who also chaired the Ag Subcommittee, because they were very, very concerned. What was happening is that little checkbox that some of you do on your airline tickets, that is a kind of an indulgence that you pay into the basket at church that gives you forgiveness for today's sins. That carbon footprint that you just offset may or may not have anything whatsoever to do with, first of all, offsetting your carbon footprint. Second of all, actually having any measurable impact on the magnitude of the problem that we think we're trying to solve. So the concern was that farmers, ranchers, forest landowners were being kind of snookered into making deals that they didn't understand and for which there was very little technical or scientific guidance about whether or not these were legitimate deals. So being paid, for example, to have 5,000 acres of your forest land in Colorado, essentially locked up from most of your management options for a period of 200 years, because you are saving the planet along with tropical rainforests, may or may not have any legitimacy. And Congress was very concerned that it was now time for the government to intervene with at least some technical guidelines prior to any discussion about regulatory intervention. So the mandate we were given, and I was kind of sucked sideways from the Yates building on 14th Street over into the Witten building on Independence, working with the Secretary's office, is how do we put together an Office of Environmental Markets that can help provide this information, can educate people about this, but not yet have any regulatory implications, because the states, particularly California, were involved in that. We were given the mandate to get to compile and educate and reach out, which I spent a ton of time. It was a really fun time running all over the country, all over the world, Brazil, Siberia, Oregon, whatever, to talk about what are the science-based methods that provide the basis of knowledge and metrics, and I'll go into this in a minute, for these environmental markets. But that wasn't the whole story. Also spent a bunch of time on Wall Street. And I pulled this quote from Goldman Sachs because they were one of about a half a dozen major investment houses with which several of us were having real live conversations about billions of dollars of standing reserve of investment money. Note that this is 2007, 2008. Everybody knows what happened at that time. But at the time, we had an enormous amount of capital that was waiting to flow somewhere. And I put this little subtitle up here because there are two things about those conversations that really stuck with me over the long term. I'll start with ROI. They were not looking for VC level ROI. I'll translate. Venture capital return on investment is typically 30 to 35%. This is high risk stuff. You know, we want to get our money back. We don't put our investors at risk. No, they're saying 7 to 15%, which is precisely the ROI that they're looking for on building a bridge for a municipality under a GO bond or a canal for some irrigation district. All they're looking for is a reasonable, stable return on investment. And that's how they were seeing environmental markets, as a potential. But the other part of my subtitle here is risk admin. I made this up, but this is basically, there are several types of risk. Could have a hurricane, could have what they call act of God, which I've never quite figured out, but maybe it's my inner Buddhist hasn't quite figured that one out. But that there are several ways that investment houses manage for risk, actuarial risk, etc. The worst risk that they kept pointing out to us is administrative risk. Us across the table going, you folks in the government keep screwing things up because you keep moving the goalposts. You can't make up your mind what a functional acre is for a wetland is. You can't really tell us what a legitimate compliance-based ton of carbon is. And we'd love to buy this stuff. We'd love to facilitate. In fact, we don't want to buy the carbon. We want to buy the ability to fix the carbon for credit, so somebody can make money on this, so we can get an ROI on our investment. That's all we're asking you. So make up your mind, is basically what Goldman Sachs was saying to us. And quite legitimately, because we were not making up our mind. These are the necessary conditions for environmental markets. These are totally the responsibility of the author. I can blame no other government agency, no other academic. This is basically me compiling about 10 years of thinking about this. But it seems to bear out. Clockwise. And this is not in a necessary order, but it tends to kind of unfold this way. You cannot have an environmental market in which you have commodified a unit of something, like a ton, an ounce, a pound, functional acre. You cannot do that unless there is a regulation that says, this is something we have to limit. So whether it's tons of CO2 equivalents in the atmosphere, we gotta limit that, or it's TMDLs, pick your total maximum daily load under the Clean Water Act, where it's, you know, only so many tons of phosphorus flowing at certain rates, or even garbage. You have to set a limit and have a regulation. We have this enormous array of environmental laws at the federal and state level that allow us to do these things, and we're doing it all the time. But you cannot have an environmental market function without the regulations being quite clear. So you're defining the problem. Second, and related and simultaneously, what's the unit of measure? Now, it's fairly easy to describe a ton of CO2 in the atmosphere that got there from your tailpipe. Pretty easy. Science is pretty settled on that. DSAs, discounted service acre years, are a little more difficult, but there's now better science on it. The dailies, anybody remember what dailies is? It's a measure of, it's your discounted annual life years, something like that, in which you basically, if you're breathing all this crap from a freeway, your dailies are going to be at a lower level and therefore subject to greater cost in the healthcare system. One example. But you have to have a metric upon which you agree. Most of these metrics for environmental markets are not directly measurable on a continuous emissions monitoring basis. That is, you don't have a meter someplace telling you, like you do for stack emissions. You can't get like daily or hourly or by the minute kind of readings on what's happening here. So you have to use models. And as all of you know, all models are wrong, some are useful. Big lesson from the world of environmental markets, and I analyzed over 60 of them during my tenure working with USDA, is if the regulatory agency does not have a model of record, and if it does not acknowledge, document, and publish the limits and uses of that model of record, there shall be a market failure. I'm going to say that axiomatically. I didn't think that 15 years ago, 10 years ago, but now I think it because I've now witnessed the failure of markets. Boise, Idaho, going through its old phosphorus mitigation on the Boise River, and finally said, forget it, we're just buying the reservoir, because we can't actually have a model that we all agree on that says, if I do this upstream and I use these certain agronomic practices, or I do this in the forest, that it results in so many pounds of phosphorus being reduced into the reservoir. And they basically couldn't agree on it. They had market failure. And it was one of my many, so I had like 3 successes in one column and 58, failures in the other column. The reason for that is that number 1 and 2 were not well designed. Number 3, the limits, there always has to be some kind of a description, whether it's geography. For CO2 equivalents, it's global, so you don't have a limit geographically, but you do have a limit on what kinds of activities are actually regulated or subject to crediting. So it's not everything that emits CO2. It's, in California, it's basically stationary power, it's industrial processes, cement, etc. There's only a certain amount of, or a certain part or sector, and I'll have a graph in a minute, that basically says, we're only going to concentrate here because we have data and we have the ability to regulate and reduce and measure that reduction. So for example, forget it, I won't get lost in that. We can talk later about it. Opportunity, and this is the part for environmental markets, is we often have number 1, 2, and 3 pretty well in hand as regulatory agencies. We are really, really nervous sometimes as regulators saying, and we want to create an opportunity for people to compete for the most efficient way of providing these reductions. And that's where the more staid and traditional regulators, I've been one, so I'm sympathetic, and I go, I'm a little bit nervous because we could have this massive efflorescence of market ideas and lots of competition, lots of innovation, lots of capital going into these new technologies. And 10 years later, we do the true up and the assessment, we find we have not affected the problem one whit. And that was the basic fear that EPA, California Air Board, etc., had about environmental markets and cap and trade. We could have just a hell of a lot of fun here. We could raise billions of dollars. We could invest in all kinds of things that don't have any real results. And that's the fear. So, and I'm very respectful of that fear. But despite all those fears, following on my tenure, I left there in 2011. NRCS, Natural Resources Conservation Service, one of the many agencies or services under Department of Ag, started a conservation finance unit. We had a program that was a carve out from a Farm Bill program that many of you may know about. It's called the EQIP program, the Environmental Quality Improvement Program. At the discretion of the director of NRCS, we were able to carve out annually between $20 and $25 million for what was called the Conservation Innovation Grant Program. There's several categories. What we did while I was there was but kind of forge two more categories. One was in water quality trading, the other was in cap and trade for greenhouse gas reduction. And we had some phenomenal applications for these grants. Typical grant amount was between 250 to 750,000, 3-year grants. The results were really pretty exciting in some cases, rather dull and anticlimactic in other cases, failures in some small cases, and that's exactly what you expect from a good grant program. So I count it all as a success. That led to the new director, Jason Weller. It's funny when your buddies suddenly become like really important people. Jason and I were kind of inventing this when we were out drinking beers one day, a long time before he became the director of NRCS, or the chief of NRCS. But we were thinking, we got to get ourselves positioned as a federal agency to really understand finance and not just kind of defer to people who know something about finance. We've got to get some expertise into our agencies where we understand what the people in three-piece suits are saying across the table from us, because we were getting rolled left and right by the three-piece suits because we didn't understand the nature of the conversation. So here was a very exciting thing that we collectively, the SIG program, the Conservation Innovation Grants Program, made several years of investment in this. This was very good. I wish I had a little more information for you, but this was the 8 states around the Ohio River Basin. For 80 years, they had Orsanco. I'm going to try to remember what that means. It's the Ohio River Sanitation something or other commission. And they had appointed people from each of the 8 states sitting on this commission. When EPRI and others brought the proposal to them that said, you guys have a major nitrogen problem. We have hypoxia in the Gulf of Mexico and in different parts of the Mississippi system. We have fish dying. We have major nitrogen pollution and algal blooms happening. How do we solve this? A lot of it came from the power plants whose atmospheric deposition into the water, binding the nitrogen into the water, was creating both nitrates and nitrites, but also ammonia and other nitrogen byproducts. Major pollution problem. What we found was that point source regulation under NPDES permits was not going to be successful, even though Duke Power, the 4 major, I'm not going to be able to roll this stuff off, it doesn't matter. The big people at the table from the big power companies were saying, we have a problem to solve. We're going to get regulated here. We can't keep pooping this stuff out in the atmosphere without mitigation. So can we use crop rotations, interplanting, land management, non-point source mitigation to reduce the amount of nitrogen, total nitrogen in the system? The answer was yes. The first trades happened in 2014. It took probably about 5 years of engineering and meeting and endless scientific debate and a lot of beer to basically come up with the structure of this trading system that my friend Jessica Fox at EPRI really took forward, and I consider it one of the great environmental market successes. She led, no single person ever does that, singly by themselves, but she led an enormous array of different kinds of governance to technology efforts that ended up solving all 4 of those corners of that diagram that we looked at a minute ago. Very exciting stuff, still in operation. Virginia was a member of Orsanco, but they did not participate in that. But they were one of the 6 states in the Chesapeake region where we also wrote into Obama's executive order on the Chesapeake an environmental markets chapter. that was based on nitrogen and phosphorus mitigation from non-point sources. We spent a ton of time on farms around Maryland, Virginia, all over the place, trying to figure out what are the actual agronomic practices that could be put in place that had a measurable effect, truthfully, a modelable effect on practice to nitrogen and phosphorus reduction to the Chesapeake. I don't know its status right now. Half of us moved on or retired. But again, I thought it had real promise. This is one of the things we funded through the SIG program. Ducks Unlimited came with a very strong proposal to manage rangelands in such a way that through easements and working landscapes, changing some of the rotation practices and grazing had a measurable impact on the amount of soil carbon that was accumulated from these practices, and those practices were paid for through partly through CO2 credits. These were not compliance credits, and these are important distinctions here. I'll repeat this. Voluntary credits are one thing. That's your check off on your Delta Airlines box. It's the, I don't mean to be cynical, but it's the feel-good credit. It's PR, it's good, it's, you know, I don't object, it's probably good money. But then there's compliance credits. And that ton better be a ton, and it better be a ton not back in the atmosphere 2 years from now. That is a compliance credit in California. These are not compliance credits. They are good idea credits, and they are demonstration. They're very important for helping people understand what the mechanisms are, helping researchers kind of figure out, did we really get carbon in the soil? Did it stay? Those are really important mechanisms to move money in those directions, but they don't satisfy California's cap and trade rules. So an important distinction here, voluntary versus compliance credits. I loved working with the Willamette Partnership in Oregon, Freshwater Trust, brilliant bunch of people there. They're the people who came up with their initial efforts were basically kilocalorie credits. I'll explain. Big problem in the Pacific Northwest, as you all know. Salmon habitat is overheated because of waterways and decline in riparian vegetation, any number of factors. Water coming out of publicly owned treatment facilities, etc. So managing the temperature regimes in the streams and tributaries in the Pacific Northwest was a major part of recovering salmon in the Northwest. In the Willamette watershed, this brilliant bunch of people said, we can probably put together a program that does more than just, oh, I promised to plant some trees next to the river, but actually uses a model in every stream reach and every tributary that shows that this kind of vegetation at this aspect on this slope will deliver this many kilocalories of temperature reduction on a seasonal basis. And you can be paid for those credits. So that's where we at USDA spent a lot of time flying out to Oregon, working with the Freshwater Trust, SIG grants, etc. And I think they were enormously successful, again, at the proof of concept level. Wasn't exactly, strictly speaking, a market, but the classic example was the new treatment facility in Medford, Oregon, actually in Ashland on Bear Creek, tributary to the road, was going to cost something like $122 million in capital investment for a great big refrigerator, and somewhere on the order of $2 to $5 million a year to run the refrigerator to cool the water so that Ashland and Medford could put their wastewater back in the stream. That was pretty expensive. For a mere $8 million, and I forget how many miles of tributary and main stem riparian habitat got planted and managed, and it's still under contract, they provided the same kilocalorie reductions in the water for that salmon habitat for $8 million. Now, if you want an economic argument for why an environmental market might be a more successful way of delivering the outcomes, that was our classic example. And we dragged those poor fellows back to Washington, D.C. constantly to tell their story because it was a very compelling story. They expanded their work, excuse me just a second, speaking of overheated water, to an ecosystem crediting regime And I, again, shamelessly pulled a table. I credit them, of course, but I didn't call Dave and said, hey, I'm using your table. But this was a very good example of what I mean in those 4 squares on that diagram. The credit categories are basically according to the kind of regulatory regimes that are in place. So you can see the Clean Water Act, you can see aquatic habitat, both Clean Water Act and the Endangered Species Act, upland habitat, again, Endangered Species Act. You can see some pretty clear lines from the regulatory requirements and regimes down to how do we manage land and resources to improve these conditions. The currencies that they call them, which are great, I like the term, are nitrogen, phosphorus, thermal or kilocalories, floodplain habitat. These are functional acres, salmon habitat. So what they were after is a whole suite of environmental markets, and particularly in the Pacific Northwest. They're active not only in Oregon, but Idaho, and their status right now, I just haven't kept up with them in the last couple of years. But I thought this really does demonstrate quite well. You have to have a currency. Exactly what are you talking about? What are you trading here? And then what are the tradable units? Again, number 1 or number 2, which is the actual metrics you must use in order to have anything to say, hey, I got this, do you need it? And somebody says, yeah, I need that. Can you give it to me? Okay, you gave it to me. Now I'm going to write you a check. That basically is a simple version of what a market looks like. Let us turn to carbon markets. Bruce, what's my time frame here? I forgot to ask. Are we all right? Yeah. Okay, okay. Again, I'm sort of redoing this diagram in the context of carbon markets. Number 1, regulation. You see that the EPA must make a finding of endangerment for CO2 or of its equivalents. And that endangerment finding was upheld in Massachusetts versus, I forget the case, but anyway, it was basically legitimate, and now EPA has the ability to regulate greenhouse gases as criteria pollutants. That is their authority. Anything outside that authority is fun and games, and they took a lot of beatings over this. But in order for anybody to have a cap and trade program for greenhouse gases, you have to have something like an endangerment finding, which is a human health finding, not an ecosystem, not a planet, not a Gaia. It's does it affect human beings, because that's the regulatory authority of EPA, is human health impacts. They made that finding. They enabled both California and other places to say, yep, now we can regulate greenhouse gases and still survive a court challenge. California went its own way. 2 beers and a little time, and I'll tell you the story of how AB 32 came about in the Ministry of the Environment in Japan, but that's another story entirely. But AB 32 started in 2004, or 2004 and 2006, and then 2017, California renewed it because it had a sunset on it. SB 32, aptly named, was basically the reauthorization of the Global Warming Solutions Act in California. That is the fundamental basis of now the regulation of the California Air Resources Board, enabling them to regulate greenhouse gas emissions and to create a cap and trade program, among many, many other measures to reduce greenhouse gases. I'll show you a couple of charts in a minute. They were pretty clear, and they had a lot of benefit of good IPCC and other work, scientific work, to say these are the CO2 and CO2 equivalents. So settling on, there's still arguments about this, and I've stopped having fun being part of those arguments about whether methane has 21, 23, or 35, or whatever factor times the CO2 equivalent. Frankly, I don't care. It doesn't really make a difference given the magnitude of the problem, but that goes for all the other criteria pollutants or greenhouse gases. They are all done as a CO2 equivalent. So when you're talking about tons reduction of emissions, you're talking about whatever gas it is calibrated against the CO2 equivalent. What is it equivalent to? Climate forcing. And I will emphasize that, especially for the science nerds in the room here, that it's basically what is actually going on here that we're trying to solve. We're trying to solve the climate forcing factors that are now increasingly in the atmosphere and affecting many, many other things that we care about. So that's why greenhouse gas matters, and that's why it was declared by AB 32, now SB 32, and under the endangerment finding, that these things have a negative detrimental impact on human health, broadly interpreted. On polar bear health is still to be determined by the courts. So number 3, what are the limits? As we said, global warming is a global problem. I don't say global warming anymore, haven't for years. I say climate change, I say global change. But what we're talking about here is not just a geography and scope, but it's, again, what are the qualifying actions that are subject to both regulation and market solutions? The 4th part of it is you have to have allowances. So California says, okay, out of the 900 million tons that we're going to have to figure out what to do with, because the great landfill in the sky is overflowing, we're going to take so many of these and say that's an allowance that can be distributed to energy companies. So let's call it, I'm just giving you numbers, 100 million allowed tons. Now we're going to give you 100 million now, but 2 years from now, it's going to be 95 million. And 10 years from now, it's going to be 50 million. Those are allowances. You get to put that in the atmosphere, our common gas landfill, right? That is not a license to pollute. I'm taking a position on this. It is not a license to pollute. It's not any more a license to pollute than it is your license to pollute this room with your CO2 once you get done using it in your metabolic process. It's basically real life. That's what it takes to run a planet with all the benefits and the BTUs and the kilocalories that matter to human beings, and the rest of the planet is basically a bunch of effluent and emissions that's going to happen. What are you going to do about it? And I'm not saying, oh, it's a good idea. I'm not saying, oh, just live with it. I'm saying this is reality. What are the real policy mechanisms? What's the real science? What are the real opportunities we create to change that equation? What's the equation? I'm not going to waste a bunch of time on this. I think you all basically know the hockey stick stuff and the temperatures, and these are horror stories. It's almost Halloween, so we get to scare ourselves with big graphs like that. But this is something we worked on, God, for months and months and months, and we basically agreed that, at least in 2007, when we published this, that this is our best macro description of carbon cycling on the planet. And we can go into the details. You can see that the ocean is a great big part of that. And you're fine to take a picture of this, but I think everybody gets to own this too. So you get a copy of the presentation too. This is all, I am public domain by definition, and I'm the dummy who left his phone on. So the bottom line here, folks, is we are 20 billion metric tons every year out of balance. The ocean, the land, whatever those green arrows are by photosynthesis, land sinks, whatever, they are overwhelmed by 20 billion tons a year. So my little tangle with the Climate Action Reserve in California, that legitimately was very proud of the early market performance, that they had 600 million tons either under contract or going under verified contract. And I'm going, bless you guys, that's great, you're setting a precedent. But that's 600 million tons of forever carbon, and that's a very, very tiny part of the 20 billion tons a year that is out of balance. We don't know if we can afford to have an excess of 2, 5, 30, 100. We don't know. And that's where the critics of climate science kind of have a heyday. It's like, well, you can't tell us for sure. Well, no, I can't tell you for sure, but we can sure now, after the 5th assessment report from IPCC, make pretty strong correlations between bad things happening on the planet, like the very rapid spin-ups that are happening with hurricanes in the Gulf because of the upper 30 meters of the water column being much warmer than history would ever suggest it was. And when that whirling wind hits that warmer water, it spins from category 3 to category 5 in a matter of hours. Never seen before. Unfortunately and sadly for many of us who back in the 1990s and early 2000s were running these predictive models, we were kind of going, yeah, it's probably one of those things that's likely to happen. Hurricanes are going to have a fast spin up. We don't know when, but it's probably likely to happen. It is no satisfaction whatsoever to talk to my friends in Switzerland and New York and people I used to work with. We go, yeah, remember we ran these models and we were kind of right. This is not an I told you so that anybody's proud of, but it was basically predictable. So I would suggest, and again, I'm being a little bit polemical here, that this really does matter in some way. I don't have the answer to it, but we can see now from IPCC reports and others that these are pretty undesirable conditions, even though we can't guarantee you that your house is going to be flooded in North Carolina in 2023. Can't do that. No actuarial could do it. But we can pretty much say that Texas flooded again this year. We might want to be thinking about this stuff a little more carefully. I don't want to dwell on this. All I want to do is say that at 1.13 degrees above pre-industrial levels, global temperature rise, we're already seeing some scary evidence. These are basically by 2100. So when your grandkids are bureaucrats like me, they're basically going to be looking at temperatures that are beyond imaginable scales of impact. I really can't wrap my ecological head around what those red numbers would look like in lived experience. I can't. But this is basically what, and again, this is not just scare tactics. These are real, enormous amount of science leads us to summarize these kinds of predictive models and say, even if we're off by, huge margins of error, 50% each side, it's still of concern. We should be thinking very, very carefully about this. So California's thinking very carefully about it. That's their vision. That's Governor Brown's vision. That's the guy I used to have intellectual wrestling matches with in the governor's office with over these visions. And of course, I was the poor guy who was stuck with fracking regulations, so I didn't have much standing in those discussions. But we can see that it's an entire picture, multiple threads, multiple fronts of policy making. So why I'm not seeing how many graduate students versus faculty, but all of you who are in the course of your career of creating solutions in this space, please understand that there is a policy world out there that must be dealt with, that has to be dealt with, that is economically sensible, that is not completely wacko, that's sustainable, that all the good science that we were doing will never ever speak for itself. It must be spoken for. And I'm urging all of you who are in the early part of your careers, rather than us crotchety old curmudgeons, to basically keep in mind that whatever you produce on the good hard sciences part, the harder sciences of political science, the social sciences, need to be involved in your discussion, because those results must be spoken and in intelligible ways. That's what California has done an incredible job of doing, and that's why they're seen so lefty and so wacko. And why I had a hell of a time getting here to Montana, because people would say, oh, this is the guy from California. He's got some wacko ideas. That's probably true. Anyway, this is the emissions profile. I'm not going to dwell on this, but you can see that transportation, electricity production, and industrial emissions are the big ones. And again, back to corner number 3 in my diagram, where you're basically describing the limits. This is really where the action is in the climate action plan, the dot works, is transportation and industrial emissions like cement, which is one of the big emitters, and electricity production. California had long struggles over buying electrons from Montana, from Colstrip, and from Wyoming. LADWP, the Department of Water and Power in LA, already has now, as of about 4 years ago, basically said we're phasing all of that out. That's one of the reasons that Colstrip is struggling a little bit. But basically, that was counted as part of our emissions budget in electricity production. So we didn't get to cheat and say, well, it doesn't count until you're over the Nevada border. We basically were saying we got to take into account all sources and mitigate them as we can. This is not worth dwelling on except to just show the same kind of story. I'm sorry, this is a hard to read slide, but the cap and trade program was expected in the scoping plan, the recent scoping plan, to deal with 191 million tons per year. The very, very significant portion of the total reductions are expected to come from those who have to get an allowance and credit in order to stay in business and keep doing what they're doing while working on their long-term solutions. But I can't do it right now. It's not affordable. It's not feasible. I don't have the technology, etc. Let me buy some credits. You only get to buy so much of them. You can't buy your way out of the problem. But let me buy some credits so that at least we can keep the economy functioning. So this is, back to my opening slide, why I said cap, trade, reduce, and improve. Because people forget that this is, thing's not saying, anyway, I'll just wave my arms here. This is the declining cap to 2030. This is now regulation. This is now law in California. And there are penalties when those bars are higher than they're supposed to be. People will pay money because they are out of compliance. That's talking about that, not the whole economy, but those big pie pieces of industrial electricity production and eventually transportation. You can see the little blue parts are offsets. What is an offset? An offset is basically, I'm going to go plant 100 acres of hemp. It's going to suck a bunch of carbon out of the atmosphere. It's going to put it into the root zone. And then I'm going to grind it up, and then I'm going to pelletize it, and then I'm going to bury it in the ocean, and I'm going to get credit because I took that carbon out of the atmosphere, and I promise you it won't get back there, at least not by something I did. Pay me $11.52 a ton to do that. It's an absurd example, but you get the picture. These are offsets that have nothing to do with electricity production or industrial production or transportation, but they offset for credit the other impacts. So I can take that over to ExxonMobil down in El Segundo and I can say, hey guys, I know you need 100 tons this next year across your operations. I can sell you with the authorization of the California Air Resources Board and the cap and trade market, I can sell you some of those credits by doing rangeland carbon in Montana, hint, hint, to basically manage Montana in such a way as to suck carbon out of the atmosphere and keep it there on your behalf while you demonstrate that you do have emission reduction strategies for either oil production or cement or cookie baking, it doesn't matter. That's the nature of the cap and trade program. So I'm going to wrap it up here. You can look at the slides later. I'm happy to have you do that. But I just want to point out a couple of the really biggies here. This is not a comprehensive list. These are just the elements of cap and trade. But you have to have additionality. That's in the second column. If you can't prove that the action that you took was not something you were already going to do, back where I grew up in Eastern Washington, that's called shooting holes in the fence and drawing bullseyes around them. That doesn't count. You basically have to prove to me that the action you took with moving your cows or growing certain things or converting to ethanol or substituting natural gas for coal, that those steps are additional and that they count as a credit. The permanence of that says, these big, big arguments over this, that's one of the things I don't miss about that world. Permanence is it forever? Is it 200 years? Is it 100 years? Is it the arc of life of the CO2 molecule? All those arguments are about, we've got to get this stuff out of the atmosphere long enough to have an effect. So 2 weeks, 2 months, 2 years ain't gonna cut it. 2 centuries, maybe. We're making some wild guesses here. But if we get enough of it out of the atmosphere for long enough that we may change biogenic carbon cycling and we may change the temperature profile on the globe. It's a lot of bets, but they're bets that we're making already. And public trust. Public trust is a key part of all of this. I say that not only are the systems, the governance, the technology trustworthy, does the public say, yeah, we have a problem, we believe we're trying to solve it, but there's also a technical and legal part of this, which is public trust doctrine. Everybody, I think, knows, or you may know, or you'll learn, that Mono Lake in California in the 1970s, those lawsuits changed the nature of public trust doctrine as a jurisprudence decision-making tool. It basically said, no, you don't get to drain this lake by taking the water someplace else down to LA and just forget about it, because there is a public trust in maintaining the integrity of this ecosystem that you cannot walk away from. There may be a public trust legal challenge. I'm not going to make it. I'm not smart enough to do it, but I've talked to enough attorneys who think there may be some grounds here eventually to say that putting excess greenhouse gases in the landfill in the sky is violating a public trust. The legal construction I leave to the scholars among you, but that to me is an exciting area for more thinking. And that, I think, takes us to the end. So, did I make it? Okay, great. My pleasure. Yeah.
Yeah, I had a question. So, what, 15, 20 years ago, we had proposals in Congress for cap and trade. And those kind of, the Congress changed, and those are no longer viable there. Now we're getting proposals, George Shultz and those talking about carbon fees. With your experience with environmental markets, how do you see kind of the politics of cap and trade versus, say, a carbon tax?
Yeah, no, it's great. That's a fundamental question. Thank you. The question was, how do you see the different, or the balance or the tension between carbon tax and cap and trade? And it's an excellent question. There's a lot of debate ongoing about this. Putting aside the margins of wackoness that's going on with Congress and federal politics right now, the more sensible middle of it, both of them, and Schultz being included in that, are basically saying there's got to be a price on carbon of some kind. Cap and trade does it competitively with a bunch of market rules, and the price finds itself. I go back to the comment I made on one of my slides that markets are not born, they're made, right? But if you make the market correctly with adequate protections, floors, ceilings, safety valves, etc., that there will be a price on carbon. Is that price adequate or sufficient to drive incentives and change in behavior? Carbon tax is a cleaner way to do it. The counter argument has for a long time been, you're going to pay that tax to the IRS, US Treasury. The US Treasury will do what with that? They'll go to Congress and say, well, you got this big bucket of money. This is happening in California with the Greenhouse Gas Reduction Fund, which I think right now stands at about $1.2 billion of unspent, unallocated money. Are you really going to trust the legislature in California or Congress to say, in our wisdom, we'll spend $1.2 billion this way, rather than having that price of carbon reflected in and distributed progressively throughout an economy? I take no position on this. It's simply, that's kind of the broader shape of the argument. It's a great question.
Are there any examples of countries, or California, for example, that have implemented a cap and trade and generated reduction in carbon?
Absolutely. I forgot to put up on my slides. I was kind of trying to compress things a little bit. California has already reached and exceeded its targets in emission reductions. And none of that can be counted, not none, but a small margin can be counted against the many critics say that would have happened 2007, 2008 because the entire economy shrank and everybody was emitting less. That turns out to be a bogus argument. You look at the GDP numbers of the participating countries in the Paris Agreement, that just didn't turn out to be true. In fact, some of those economies actually grew. This is a weird story to tell, and the analogy would be water in Los Angeles. Los Angeles, with twice as many people now, uses half the amount of water that it used in the 1970s. That's because you cannot build a house without a 1.6 liter low flush toilet. You forget the gardens in Hancock Park and all that stuff. Everybody argues, but the macro numbers say that those reductions are very, very real. Same thing in California. The emissions are actually real with a growing economy, growing number of people. There's almost 40 million people in the state now. And they've been pretty successful. Now, does it cover the $20 billion deficit? Not dollar, what did I say? 20 billion ton deficit, no. But it is a significant signal to the rest of the world. Yes, this can be done. And a thriving economy in renewable energy, new technologies, even wacko lithium batteries in Nevada, these things are now evolving as economic contributors and emission reductions. So that was a long-winded answer to your question, but I think the proof of concept phase is probably done by now.
In Europe, are any of them very successful?
No, and that was because of poor market design. The European ETS, the emission trading system, basically collapsed around 2008, 2009, I forget. It went from somewhere in the 7s and 6s a ton to slam into $1.50 because of manipulation of the market, false tons, and lack of oversight. There was no highway patrol out there handing out tickets. So that was a market design, market management problem, but it wasn't necessarily a failure of the ability to reduce emissions.
Can you discuss British Columbia's carbon tax or revenue neutral?
I can't really. I kind of have the newspaper level that many people do. I was excited about them passing it because I'm excited about anybody passing anything of any significance in public policy space to reduce emissions, but I haven't really studied it.
One more question.
Just a bit of a follow-up on the effectiveness globally of these markets. Do you have any examples of existing or maybe forthcoming scale at the global level of markets that might lead us to have an impact on future systems of feeding 9.5 billion people, healthy marine and terrestrial environments? Or, where are the problem children? Is it the big continents, Asia, India? What are we looking at in our lifetimes?
Yes. You would save that for 12, 15 hours. that to me is, it has a deep emotional gut level to me. That is to me the problem that will only be solved by incredible intelligence investment and Manhattan Project globally investment. My early career was actually in development in Latin America, where I saw an incredible regional economy difference from one power line going into the middle of, in this case, the Meseta, the Tarascan Mesa. How do you say it in English? Meseta Tarasca in the state of Michoacan. And that electrification, as Lenin said when he was asked in 1919, what's the key to the success of the Soviet Revolution? He said Soviets, which are the governance system, and electrification. The impact of electrons stimulating the economy and well-being and health of that region was inescapable. That to me is part of the passion, is I am not about to deny those people good health care opportunities now with broadband, global reach. You go to Africa, there's almost no wired infrastructure, but everybody's got a cell phone, same in China. The technology solutions are there, but I'm not about to say who lives or dies. And so that growing population on the planet and the increasing demand for well-being at the same time, by nature, BTUs and kilocalories being the metrics we use, how do we do that without screwing it up? I got past 1 o'clock without giving you an answer. I restated your question.
Yeah.